Hi everyone, I'm Mary Ellen with Headwaters Science Institute, and I'm back with another Thursday Science Challenge for you. It's springtime in the Sierra, and it gets windy with some small storms that come through. I'm going to take advantage of these winds and measure the wind, and I'm going to show you how to do it too. How do you measure something you can't see? Scientists use a tool called an anemometer. Wind speeds can be measured with a Robinson cup anemometer. The first cup anemometer was invented by Thomas Robinson in Ireland in 1850. He actually published his first scientific paper when he was 13 years old. Anemometers give us information that's really useful. Engineers use wind speeds to know where you can put a wind turbine. Weather forecasters use the wind to predict the weather. Sailors need information on wind to know whether they can go out and sail. Airports need wind information to know if it's safe to send aircraft out. In the winter, you need wind measurements to know what the wind chill factor is. And around here, the ski areas need wind information to know whether they can run their chairlifts. So your challenge is to make an anemometer and make some kind of prediction around your house. You could predict where it might be the best place to put a protected garden, or you could predict where it might be a good place to put a wind chime so you could hear it. Or you might want to predict what the wind speeds will be at your house on an incoming storm. So let's take advantage of this wind coming up and measure the wind. Here's some things you can collect to make an anemometer. Actually, you can make two anemometers out of this picture. On the left, you'll need some small pieces of cardboard. Those pieces aren't any longer than 10 inches. A ruler, a stapler, scissors, pencil with a push pin, and any kind of little paper cup that you can find. On the right, you could use some straws if you have them, and then if you have any of those little takeout plastic cups, those work as well. You can use paper cups for the one on the right as well. All right, let's make an anemometer. I have a piece of cardboard that I measured at 9 inches long, and then I measured out an inch from the side and then another inch. So I'm going to take that and cut it on the red line. So I have two strips that are 9 inches by 1 inch. If you only have cardboard that's 7 inches long, that's okay too. That will work. It doesn't have to be exact 9 inches. Then I'm going to take two pieces of cardboard and cross them so they're as even as I can get them on each side, and then staple them in the middle. My next step is to take one of my cups, and I'm going to take my pen and color just one of my cups. I want to make it so it's different and obvious than the other cups. I think I might have to get out a black pen to make it more obvious, but I will do that later. Then I'm going to take my cross and I'm going to take my cup and staple it to the end of the cardboard like that. Yep. Now I take my next cup and do the same thing and make sure they're going the same direction. You don't want them like that. I went ahead and colored that one cup with a dark black just so I could see it really easily. The last thing you need to do on this design is take your push pin and go through the top like that and then do a pencil and a pencil eraser through the bottom. And now you have an anemometer that spins. That's that design. What you can do with these, if you have these around your house, is take a paper cup, and I'm going to punch 4 holes equal distance around the rim of the cup. So I got one there, and then I put my thumb below, and I've got one there, and then I'm going to go halfway around and do one here, and then opposite of that one is there. So now I have a cup with 4 holes. I'm going to take my straws and thread it through the holes like this. And the next thing to add are the cups. And I happen to have some little to-go cups, so I'm going to use these. And you want to take them and orient them like your other one so that they're perpendicular. I'm going to take a stapler and smash down the straw and staple it like that. Okay, now I've got the cups all on, and they're pointing all the same direction, just like the other anemometer, and all I need is the part that it spins on. So take a pencil and poke a hole in the bottom and wiggle it around so there's a lot of extra room. Then flip it around and put the eraser up through the hole, and take a push pin and poke it through both straws and into the eraser. Whoosh. And you don't have to push it all the way down because you want it to have some room to spin. And now I have an anemometer that spins. Okay, I'm pretty excited because it's a really windy day out here on the lake, and I'm going to try and get a baseline max wind speed before I go back and measure it at my house. So we usually measure wind on water in knots, and we also measure wind by miles per hour, but because of my simple tool, we're going to measure it in revolutions per minute, and that's why I colored one of them dark. So I'm going to count every time that one comes by my finger for a whole minute. So hopefully my little anemometer will hold up and we can get a measurement. So I got my watch, I got my anemometer, and we're going to let it rip. Wow, that was challenging. I actually did it 3 or 4 times just to get an average. And the average that I came up with was 85 revolutions per minute. Now I'm back in my house and it's still pretty windy. My prediction is going to be which side of my house is going to be more protected for a garden. And I'm going to say the east side is. Right now I'm on the west, so I'm going to test the wind on the west. So I'm going to count it for a whole minute starting right now. "13. Here I am on the east side, ready to do my count. Ready, go. Wow, 37. So once again, my data didn't support my prediction, but it's all good information because now I know where to put my garden. So make an anemometer, find a windy day like today, and go see what you can find. There's all sorts of questions you can ask. You can figure out if it's windier in the morning or the middle of the day or the afternoon, or you can see if structures change your wind speed. If you hang on a minute, I'm going to show you a really cool equation where you can change the revolutions per minute into wind speed, and so we can actually see how fast it was blowing today. If you're curious what all those revolutions mean in wind speed, here's a fun equation you can use. Look at the equation at the top of the page. All you need are your revolutions per minute times pi, which is a constant at 3.14, times the diameter of your anemometer divided by 60 seconds. So I went back to my anemometer and I measured from cup to cup and I came up with 25 centimeters. So all I had to do was plug in all those numbers. I went for the windiest spot I was on the lake at 85. So 85 revolutions per minute times 3.14 times 25 centimeters divided by 60 seconds becomes 6,672 centimeters per 60 seconds. If I divide the numerator by the denominator, I end up with 111 centimeters per second. Your superior challenge would be to change that to miles per hour, but I'm going to let you figure that on your own. So good luck in your investigation, and please share with us anything you find out about the wind. See you next week.